Okay, now we are at class work 1. If you have done this question and you are stuck, then you refer to this video. If you have not started on this question, I suggest you spend a good 10 minutes to do this question first before you look at this video for the solution. So let's look at the question. In the diagram, O is the center of the circle. They give you the center of the circle. Most probably they give you the diameter. Okay, right. Diameter is here. A, B, C, and D are the points on the circle such that B, O, D, E is a straight line. Okay. CE is a tangent. So I have a tangent as well. Okay, so what can I think of right now? I have diameter. I will think of tangent perpendicular to radius. Yes, no? No. I have a diameter. I will think about right angle in a semicircle. But if I have a tangent, what can I think of? Yes, tangent perpendicular to radius or tangent from an external point. Okay, so let's see which will work. The first question, they want me to find OCE. OCE. Oh, it's this angle. OCE. What would that reason be? Let me just do it here. Angle OCE is 90 degree. The reason is tangent perpendicular to radius. Tangent perpendicular to radius. Or radius perpendicular to tangent is the same. Okay, but you have to state reason even if it's 1 mark. Part B, ODC. ODC. ODC is here. I have 90 degree. ODC. With ODC, ODC is part of a triangle ODC. So if I can find DOC, I can find ODC. How to find DOC? Angle DOC is equals to 180, take away 90, take away 28. By focusing on triangle OEC, you will get 62. Is it 62? Okay, so for this will be angle sum of triangle. Angle sum of triangle. But that's not all, because they want ODC. So ODC is 180, take away 62, divided by 2, which is 59. Okay, for this reason, it's base angles of isosceles triangle. Base angle of isosceles triangle. I'm writing my answers here, but for your case, you write below. I'm writing here so that I can refer to the diagram and show you what I'm doing. Part C, DAC. But before that, a good habit will be to update neatly the answers that you have found. DOC is 62. ODC is 59. Okay, by writing down, it will give you more values to, or more angles to find the other angles. Now angle DAC. DAC. Okay, now they want this angle. We have used tangent perpendicular to radius. We have used angle sum of triangle, base angle of isosceles triangle. There are so many other properties. Okay, if you stare at 62, 62 is actually angle at the center. Okay, if you stare at 62, 62 is actually angle at the center. Coming out from point D and point C, if you go out from point D and point C again, you will reach the circumference at A. Okay, so angle at center is actually twice angle at circumference. I can conclude what is the angle DAC. It will be 31, half of 62. So angle DAC equals to 62 divided by 2, you get 31. Angle at center equal 2 times angle at circumference. Okay. So I updated on the diagram 31 degree. Next question, DBC. DBC. They want this angle over here. Oh, okay. This may not be obvious, but there are two ways to do this. This can also be seen as an angle at center, 62 degree, divided by 2 to get angle DBC, because it is also angle at the circumference coming out from point D and point C. You see, I can also extend my red line from D to B, from C to B. So this is also 31. Can you see that this is also 31? Angle at center is 62. Twice angle at circumference at DBC. So it's also 31. This is one way of seeing it, that is 31. Another way of seeing it is if you can see the butterfly. Let me shade the butterfly in blue. Can you see the butterfly? Okay, if you can see the butterfly wings, that means you use the reason of angles in the same segment. So whichever you want, you can write down the reason. I will choose angle in the same segment. DBC equals to 31 degree as well. Angles in the same segment. Okay, there may be more than one reasons. Okay, maybe 2 to 3 reasons to get to the same answer of 31 degree. Depends on what you see first. So it is okay if your reasons are different from your classmates' reasons. Okay, but the fastest so far I noticed will be this, angles in the same segment. Okay, now part E, the last one. Part E, if you read carefully, what they want is angle ACB. 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 This angle over here. Okay, this angle ACB. And they also give you a free gift. They give you a free gift of 35 degree. So make sure you use this. ABD is 35 degree. But there's no line joining A to B. Let me extend the line. Let me draw a line from A to B. ABD. Let me draw it again. ABD. ABD is 35. How will this help you? This is 35. What can you see? I see another butterfly. Can you see the other butterfly? What if I highlight this for you? Okay, you may see some other properties, but I see this butterfly, which tells me that this is also 35. Alright, so I write down angle ACD is also 35. Angles in the same segment. Okay, angles in the same segment. After which I will use 90 degree, which is DCB, to take away that. Angle DCB is 90 degree. I've not used this. This is a right angle in a semicircle. That's why it is 2 marks. Therefore, angle ACB, you take 90 degree, take away 35 degree, you get 55 degree. There's no reason for this. Okay, the two reasons I've given in the previous part already: right angle in the semicircle, angles in the same segment. Okay, I hope you enjoyed this question. After doing this question, can you proceed on to class work 2?